In this video, we will learn about integration by parts. Integration by parts can be thought of as the reverse product rule for integrals, basically. We will also learn an acronym called LIATE that will help us determine how to use integration by parts effectively. To see where integration by parts comes from, let's review the product rule. So the product rule is the derivative of two functions, u times v, equals u prime v plus v prime u. And in this case, I'm going to write them with the dx's. Like that. And now, it's kind of strange, but in calculus we take the derivative of everything, and then in calculus later we take the integral of everything. And so what we're going to do is, after differentiating, we're going to take the integral right away, and we're going to take the integral with respect to dx on all of these terms. Alright, and I know it's kind of weird, but get used to it, because that's how we're going to do this. And now watch what happens. In this first term, notice that the dx's cancel. Okay, and because we take the integral of a derivative, what we end up with is simply u times v. And then in the second integral, what we end up with is a very similar thing, where the dx's will cancel, and we're left with the integral of v du. Okay, so here's the v, and here's the du. And then the third integral, this last one, sort of is the opposite. The same thing happens where the dx's cancel, and instead of v du, we get the integral of, here it is, u, and then dv. Alright, so this is you can sort of view this as like the rewriting of the product rule, and then for integration by parts, the way we're going to write this is simply, we're going to subtract this term to the other side, and so the integration by parts that you'll see in textbooks is this. Ta-da! Just take a second and admire this equation. It's very nice. This is integration by parts. Let's see how to use this. Integration by parts comes up most often when we are trying to integrate the product of two different types of functions. So, for example, this integral of sine of x dx. Technically, this is two different types of functions. Alright, the different types of functions that we're going to use are the following. They form this acronym, LIATE. They are logarithmic functions, logarithmic. I stands for inverse trig, so things like arcsine, arctangent, etc. A stands for algebraic, so things like x, x squared, x to the fifth, 7x squared, etc. T stands for regular trig, so sine, cosine, etc. And then E stands for exponential, so things like e to the x, 2 to the x, etc. So sine of x, the integral of sine of x dx we can do normally. This is simply negative cosine of x dx. We don't need to do integration by parts for this. So not integration by parts, although technically you do have two different types of functions, because you have dx, and dx is an algebraic function. You could think of it as 1 times dx. And then sine of x is a trig function. And so you could see, you want to start noticing what kinds of functions do we have. Now, a classic example of integration by parts is this. That's kind of weird. Okay, x times sine of x dx. This is not a basic rule. We need to use a different tool for this. We cannot use u-substitution, so let's try integration by parts. Do you see two different kinds of functions? I do, because I highlighted them in different colors for you. Great. Here's x, and x is an algebraic function. And here's sine of x, and sine of x is a trig function. Now here's the nice thing about LIATE. What you want to do is figure out which one comes first. Okay? A. Great. No, wrong color. Okay, we have an A, and we have a T. Okay? And what we're trying to do is we're trying to get our integral to match the form of the whole u dv thing. Okay, this is what we're trying to get. So in order to do this, we need to figure out what u is and what dv is. The LIATE method is an easy way to determine which is which. Here's how we do it. We have a and t. The first one in the list is u. Pretty simple. The second one in the list is dv. So what we're going to do is we're going to set up a little chart to help us organize our thoughts. Here's the chart. we want to set up u and du, and then sort of flip it because we're integrating u dv, so we'll have dv on top and then v on the bottom, like that. Okay, and now all we have to do is just fill out the parts. We said that the u was the first thing in the Liate acronym, which is the a, and so u is simply going to be x. And then dv is going to be the sine of x, and we have to include the dx always with the dv. So really dv is sine of x dx. Alright, to go from u to du, we take the derivative. The derivative of x is dx. To go from dv to v, we have to integrate. So there's like a minor integration step in here. We integrate both sides, and the integral of sine x dx is negative cosine x. Notice I didn't include the plus c. That'll come all the way at the end. Don't worry about it for now. And now integration by parts is pretty straightforward, because we said that earlier, using our magical formula, that the integral of u dv was uv minus the integral of v du. Okay, sorry for the v's looking like u's. V du. So uv minus v du. And so I like to use something called the shape, and the shape looks like this. Ta-da! Where does the shape go, you ask? Well, it goes right here, because we're going to connect uv and then v du. Because now the shape tells us that we're going to multiply u times v, which is this term right here, and so we're going to get x times negative cosine, make sure you use parentheses, minus the integral, yes, we have to do another integral, sorry, get over it, of v, okay, now we're connecting these two, v, which is negative cosine x, du, and du is dx. So you can see that all the pieces go somewhere, okay? And now we can continue this. So we can simplify this first term to be negative x, so I'm going to keep the negative as red because it came with the cosine. So we have negative x cosine x, and then now we have to do a little bit more integration. Notice that these two negatives will become a positive. This is something that often happens. And then the integral of cosine x dx is positive sine. So we're just going to add back a plus sine of x, and now we can add the plus c because this is an indefinite integral, so we add the plus c. Notice that the dx goes away because we integrate, and so this is in fact our answer. Kind of a weird function, but that's how it works. I'm going to set up some other integration by parts examples and then just do the whole like the u dv what's what, so we can see this. So let's do some other classic examples. One of them is now we can integrate things like arctan of x dx that we were previously unable to do. Now, in this case, we want to identify, can we do this normally? No. Can we do a u-sub? No. So let's do integration by parts. Notice that we do have two different types of functions. We have an inverse trig, which is not a, sorry, inverse trig, which is I, and we have an algebraic function a, and so using Liate, notice that the I comes first, I before A, except after L, I don't know, whatever. I comes first, and so I is going to be the U, so let's set up our little chart, U du, dv v. So u is arctan, and then the dv is simply dx. That makes it really nice to put there. And so now to find du, we take the derivative of arctan of x, and the derivative of arctan is 1 over 1 plus x squared. And then to find v, we have to integrate dv, and so integrating dx, we get x. So that was pretty straightforward. Now we can use the shape like that. And so this integral becomes uv, which is x times arctan x, minus the integral of v du, which is x divided by 1 plus x squared. Okay, so notice that we have another integral to do. And actually, with the du here, I forgot to add the dx on the top, so you need to remember that because you have to do this integral now. And to do this integral, this is not basic, but we can use a u-substitution, which is very nice. So, and this is something that happens sometimes. You get done with integration by parts, and you have to do more integrals, which is always fun. So u equals 1 plus x squared, therefore du is 2x dx. So I'm going to doctor with a 2, counterbalance with a 1/2 on the outside, and then bringing everything down, my original integral will equal x arctan x minus 1/2 from the u sub, and then our u sub integral is going to be the integral of 2x dx, which is du, divided by 1 plus x squared, which was u, and so this is a natural log. We're going to have 1/2 ln absolute value u, which is 1 plus x squared. I just subbed it back in for the ending, and then we can add our plus c. And so you can see that integration by parts is kind of weird because we're integrating, inverse trig and algebraic terms, and we end up with a log term at the end, which is, it's kind of one of the weird things about calculus. So hopefully this gives you a better idea as to how to set up the integration by parts. In the next video, we'll talk about some other things that can happen with this.